Good morning, students. Let's start a new chapter, Surface Chemistry. Surface chemistry is that branch of chemistry which deals with the study of the phenomena occurring at the surface or interface, means at the boundary separating two bulk faces. The two bulk phases can be pure compounds or solutions. The interface is represented by putting a hyphen or a slash between two bulk phases involved. As for example, solid liquid or solid or liquid. No interface exists between gases as they are completely miscible. Important phenomena occur at the interface is dissolutions, crystallizations, corrosion, heterogeneous crystallizes, electrode processes, etc. Absorption. Definition of absorption: the phenomenon of attracting the retaining the molecules of a substance on the surface of a liquid or solid, resulting in the higher concentration of the molecules on the surface, is called adsorption. Adsorption of gases at metal surface is called occlusion. Now, adsorbate and adsorbent. The substance which gets adsorbed on any surface is called adsorbate. For example, if a gas gets adsorbed on the surface of a solid, then the gas is termed as the adsorbate, and the substance on the surface of which adsorption takes place is called adsorbent. Adsorbent may be a solid or liquid. As for example, metal powders, powdered charcoal, animal charcoal, silica powder, etc. These are commonly used as adsorbent. Now, desorptions. The removal of the adsorbed substance from a surface is called desorption. This can be done by the heating or reducing the pressure of the system. Now, absorption. When the molecules of a substance are uniformly distributed throughout the body of a solid or liquid, this phenomenon is called absorption. Now, absorption. The phenomenon in which adsorption and absorption occurs simultaneously is called absorption. Dyes are absorbed as well as adsorbed in cotton fiber. Adsorption is instantaneous, means a fast process, while absorption is a slow process. Difference between adsorption and absorption. Main points of difference between adsorption and absorption are: first, adsorption is a surface phenomenon, while absorption is concerns with the whole mass of the absorbent. Absorption. In absorption, the substance is only retained the surface and does not go into the bulk or interior of the solid or liquid. And absorption implies that a substance is uniformly distributed through the body of the solid or liquid. Third difference, in absorption, the concentration of the absorbed molecules is always greater at the free phase. But other side, in absorption, the concentration is low. Absorption is rapid in the beginning and slows down to attain equilibrium, while absorption occurs at the uniform rate. Examples of absorption. First, water vapors are absorbed by calcium chloride. Second example, ammonia is absorbed by charcoal. Next, decolorization of sugar solution by activated or animal charcoal. And other example, ink is absorbed by blotting paper. Now examples of absorption. Water vapors are absorbed by anhydrous silica gel. And second, ammonia is absorbed in water forming NH4OH. Now, mechanism of absorption. Only the surface atoms of an absorbent play an active role in absorption. These atoms possess unbalanced forces of various types of van der Waals forces and chemical bond forces. Due to residual or unbalanced inward forces of attraction or free valencies at the surface, liquids and solids have the property to attract and retain the molecules of a gas or dissolved substance on to their surface. Characteristics of absorption. Absorption refers to the existence of a higher concentration of any particular component at the surface of a liquid or a solid phase. Absorption is invariable accompanied by evolution of heat, means it is an exothermic process. In other words, delta H of absorption is always negative. When a gas is absorbed, the freedom of movement of its molecules become restricted. On account of it, decrease in the entropy of the gas after absorption. means delta S is negative. Absorption is thus accompanied by decrease in enthalpy as well as the decrease in entropy of the system, and hence delta G also decreases. Absorption is accompanied by decrease in the delta G, means free energy change of the system when delta G is equal to 0. Absorption equilibrium is said to be established. For a process to be spontaneous, the thermodynamic requirement is that delta G must be negative, means there is decrease in free energy. On the basis of Gibbs Helmholtz equation, delta G is equal to delta H minus T delta S. Delta G can be negative if delta H has sufficiently high negative value and T delta S has positive value. Now, classification of absorption. Absorption can be classified in two categories as described as physical absorption and chemical absorption. Physical absorption. If the forces of attraction existing between absorbate and absorbent are van der Waals forces, the absorption is called physical absorption. This type of absorption is also known as physisorption or van der Waals absorption. It can be easily reversed by heating or decreasing the pressure. Now, chemical absorption. If the forces of attraction existing between absorbate particles and absorbent are almost of the same strength as chemical bonds, the absorption is called chemical absorption. This type of absorption is also called as chemisorption or Langmuir absorption. This type of absorption cannot be easily reversed. Now, comparison between physisorption and chemisorption. Physisorption means van der Waals absorption. First point of comparison, in physisorption, low heat of absorption usually in range, and the range of 20 to 40 kilojoule per mole, and in chemisorption, high heat of absorption in the range of 50 to 400 kilojoule mole. Now, in physisorption, force of the attraction are van der Waals forces, and in chemisorption, forces of attraction are chemical bond forces. Third comparison, in the side of physisorption, it is reversible, means physisorption is reversible but chemisorption is irreversible. And physisorption usually takes place at a low temperature and decrease with increasing temperature. And chemisorption takes place at high temperature. Physisorption is related to the case of liquefaction of the gas, and chemisorption is not related. Physisorption forms multimolecular layers, and chemisorption forms monomolecular layers. Physisorption does not require any activation energy, but chemisorption requires high activation energy. In physisorption side, high pressure is favorable. Decrease of pressure causes desorption. And in side of chemisorption, high pressure is favorable. Decrease of pressure does not cause desorption. And physisorption is not very specific, but chemisorption is highly specific. Other topics will next time. Till then, goodbye.